Our next transformation is a rotation. Do you know what a rotation is? You're right, a rotation is just a turn. And there's two directions that we turn. We either turn clockwise, and I put the little arrow there, or counterclockwise. Those are our two directions, clockwise and counterclockwise. And if you're ever confused which is which, what do you think you could look at in the classroom to help you? You are right, you can look at the clock. So here is clockwise, just showing here, clockwise goes in the way that the second hand goes around a clock, and counterclockwise goes the opposite way of a clock, right? And objects are always rotated or turned around a point. We turn objects around a point. So in class, we gave you these arrows that are like hooked together around a point. And you can use the arrow to help you on the homework. You can use the arrow even on the quiz and the test. And there's several rotation points on the arrow, but we start with the star, which is right in the middle. So if you look at here on the notes, you see these stars that are right in the middle of the arrows. That's going to be our rotation point. And we're going to take this arrow and rotate it 90 degrees or a quarter turn clockwise. And if you take your arrow, rotate it 90 degrees clockwise, it's going to point to the right. Notice that the body of the arrow overlaps the original body of the arrow because of that rotation point. Notice also it's not a stick arrow, it's a block arrow, right? And that would be how you draw it. If I want to go 180 degrees or half a turn, or basically turn this arrow upside down, this is what it would look like. Upside down, like this. Body of the arrows overlap. Now you got hang of it, 270 degrees or 3/4 of a turn clockwise is going to point here. Now notice my arrow is not perfect, right? It doesn't have to be perfect, but it has to be in the right position and it has to have the body of the arrows overlapping. What about 360? How many degrees is 360 is like a whole turn, right? All the way around. So the arrow is just going to end right back up where it started and just overlap the original arrow is 360 degrees. So those are the clockwise turns, 90, 180, 270, 360. Now, if we do counterclockwise, we're going to have some of the same pictures. You'll see 90 degrees counterclockwise is a quarter turn this way. It's kind of like being quarter till the hour, right? 15 minutes before, a quarter of a turn before. There's 90 degrees counterclockwise. 180 degrees counterclockwise is a half a turn. Again, we'll point down with the body of the arrow overlapping. 270 degrees counterclockwise is 3/4 of a turn. The arrow is going to end up overlapping the body but pointing this way. And finally, 360 degrees is a full turn, and again, it lands right on top of itself. It didn't matter if we went clockwise or counterclockwise. So you notice that some of the pictures are the same, so let's talk about them. If I did 90 degrees clockwise, this picture here, which one is that the same as for counterclockwise? You're right, 270 degrees counterclockwise. So we say 90 degrees clockwise matches always up with 270 counterclockwise. What about 180 clockwise? Which one is this the same as? You're right, it's the same as 180 counterclockwise. It doesn't matter when I turn it halfway, if I go to the right or the left, it's going to be upside down either way. 270 degrees clockwise, well, 270 degrees clockwise, that matches with 90 degrees counterclockwise. Or I like to say 45 minutes past the hour is the same as quarter till. And that leaves us with the 360, which of course matches 360 clockwise, 360 counterclockwise. When you go all the way around, it doesn't matter which way you go. So these rules are always true. Now we get to these questions, which are a little bit tricky for people. Describe the clockwise and counterclockwise rotations that takes P to P prime. This is the tricky part, P to P prime. So I'm going to make a little note. Always start at P. Start at the plane P. Start at plane P. So where's plane P? I'm just going to circle it in each problem. There's the plane P. That's where I'm going to start from. And then I'm going to go in two directions, clockwise and counterclockwise. Clockwise goes to the right. Clockwise, I'll fill in all the clockwises first. There's clockwise and there's clockwise. It goes to the right. It's not necessarily the short way or the long way. It's just to the right. Right? And you're going to say, how many degrees is that? Let's remember, how many degrees are in a circle? Right, 360. So if I'm starting here, it looks like this is a 90-degree angle, right? So if I go like the long way, isn't that 360 minus 90 or 270 degrees? What if I went counterclockwise? That's going to be just the 90. So together, the clockwise and the counterclockwise are going to add up to 360. How many degrees clockwise in number 10? Right, 180. How many degrees counterclockwise? Also 180. 360 minus 180. You're never going to need a protractor, right? The angle will either be given to you, like here it was 90, or here I see 30. So this little angle here is 30. If I were to go the long way or the counterclockwise way, 360 minus 30 is 330. Here the clockwise way is the 140, and the counterclockwise way, 360 minus 140. 360 minus 140 is 220. So those will take a little bit of getting used to, but the main thing is people say I don't know where to start. Start at the plane P. Helps me to circle it, helps me to write in those arrows, helps me to use two different colors. The last part is rotating an ordered pair 90, 180, 270, and 360. Well, 360 is just going to take us back to the start. So there's some rules for it, and here's the good news. You don't have to memorize these rules. So if I start with 2, 4, here's 2, 1, 2, 3, 4. There's 2, 4. So it's like 2, 4 is the XY. If I rotate that 90 degrees clockwise, it says that I'm going to land on 4, negative 2. I'm just following the rule. Y, negative X. So I'm going to graph 4, negative 2. That's the 90-degree clockwise rotation. To do 180 degrees rotation, it says take the original point, 2, 4, and change the signs, negative 2, negative 4. So negative 2, negative 4. So I'm going to graph negative 2, negative 4. 1, 2, 3, 4. Negative 2, negative 4. That's the 180-degree rotation. The 270-degree rotation says take 2, 4 and change it to negative YX or negative 4, 2. So negative 4, 2 is the 270-degree rotation. And if you do it correct, you get basically a circle of these points. But all I'm doing each time is just following the rule, which you don't have to memorize. So let's try it again for the next one. Next one, the original ordered pair now is in this quadrant, negative 3, 5. So it's up here, negative 3, 5. Negative 3, 5. If I follow the rule for 90 degrees, it says y negative x. Well, the negative of negative 3 is 3. So it's going to be 5, 3. 90 degrees. 180 degrees, you go back to the original one, negative 3, 5, and it says change the signs of each one. So it's going to become 3, negative 5. 3, negative 5 down here. And then the last one says take the original ordered pair and make it negative YX. So negative 5, negative 3. And you'll know you do it right if you get one in every quadrant. Negative 5, that's a negative 3. So -5, -3. And again, I have 1 in every quadrant. Now the good news is I actually don't even make you graph all of them on the homework or on the quiz. I don't even think you have to graph them. I think you can just follow the rules, but we'll see. We'll do it 2 more times. Okay, -2, -3, if I change it, -2, -3 is going to become 3, 2. No, sorry. -2, -3 is going to become -3, 2. Here, -2, -3 is going to become 2, 3. And here, -2, -3 is going to become, what, -y, so that's 3, -2. So you don't have to even graph them on the homework. You can just follow the rules, following the rules. So just to make this video not too long, I'll do this last one real quick. So 4, -1 is my original. Y -x is going to become -1, -4. It helps me really to write them out each time. Write out the original 4, -1, and then -x, -y is going to become -4, 1. And then here, if I do the original 4, -1, -y is 1, 4, 1, 4. And if I were to graph all of these, I would get that circle in each one. Okay? So you don't have to memorize those rules, and that is rotations. Rotations is the toughest one. Rotations.